So in this session, we'll discuss from February, March, May, June, and October, November session 2021 planning of the experiment. That's normally last question in paper 6. So how you plan an experiment? The first one, this question, this is from February, March paper. Old concrete contain calcium carbonate and calcium carbonate react with hydrochloric acid. So calcium carbonate plus hydrochloric acid gives calcium chloride, water, and carbon dioxide. We have to plan an investigation to find out the two lumps of a concrete contain, we have to plan investigation to find which of the two lumps of a concrete contain a large percentage of calcium carbonate, or which sample of a concrete contain greater amount of calcium carbonate. Your plan should include how you'll use your results to determine which one of the two lumps has a larger percentage of calcium carbonate. And you have access to all common lab apparatus and supply of a dilute hydrochloric acid. So first what we will do, we will take equal amount, take equal masses of the two lumps of concrete, example A and B. And we know, as I mentioned here, this concrete, the lump of a concrete contain calcium carbonate. So example, these red spots are representing the calcium carbonate. So we'll measure or we'll take equal masses of the two lumps. And because these are lumps, so to increase the rate of a reaction, we can crush them using mortar or pestle. We can crush them so that they will have a large surface area or react faster. After that, we will add using a measuring cylinder or using a pipette or burette, we can add hydrochloric acid. So we'll add HCl in both of them. HCl will only react with calcium carbonate. So as HCl will react with calcium carbonate, what will happen? It will dissolve. As you can see, calcium carbonate react with hydrochloric acid, gives calcium chloride. Calcium chloride is a soluble salt. So the concrete, what it contains calcium carbonate, that calcium carbonate will dissolve and the size or the mass of the concrete will start to decrease. How we will know which one contain greater proportion or a greater mass of a limestone or calcium carbonate? So we'll compare the change in the mass. Like example, the sample A is 2 gram, sample B was also 2 gram. But once we carried out the reaction, we add hydrochloric acid, then we filter and dry and we reweight again. Example, the mass after the reaction is 1.5 for sample A, and mass after adding hydrochloric acid, the mass of a sample for B, say it is 1 gram. So how we can identify which one having a greater amount? Because the calcium carbonate is reacting with hydrochloric acid. So the one which show a greater change in the mass, it means that contain a greater proportion of calcium carbonate. So the change in mass here is 1 gram. An example, the change in mass is 0.5 gram. So when I compare which contain greater amount of calcium carbonate, so it means B contain greater amount of calcium carbonate. So how you write the experiment, this is how you will make up this experiment, but how to write this experiment. So we will take equal mass of two samples of concrete. So the steps which are related to this experiment. So we will take equal mass of concrete by using balance. You can also mention like take 2 grams of each concrete. Then we can crush them or we can add hydrochloric acid by using measuring cylinder, or you can mention burette, or you can mention a pipette. But because this experiment does not require the measurement, that's why we can use a measuring cylinder, as it is advantages that we can add quickly. So add hydrochloric acid by using a measuring cylinder until no more react or hydrochloric acid is in excess. Then what we will do, we will filter to remove unreacted concrete. And we will dry the concrete. And we will reweight again. By the balance. And then how we will know which contain, because the sample of a concrete which contain a greater proportion of a calcium carbonate will show a greater change in mass, because the calcium carbonate will react with hydrochloric acid. If it contain a small amount of calcium carbonate, a small change in mass is there. But as it contain, if it contain greater proportion of calcium carbonate, so the mass or the change in mass will be higher. So we'll compare the change in mass. The sample which shows greater change in the mass contain greater amount of calcium carbonate. So this was the whole experiment. So we are doing the experiments from 2021 sessions. So this was one of the paper, and the next paper is from summer. So this is from May, June 2021, paper 6.1, so variant 1. In the question, we have a dilute hydrochloric acid which react with calcium carbonate to make a carbon dioxide. So give off carbon dioxide gas is given off. The apparatus shown in the diagram can be used to follow the progress of a reaction. Like we can use it to measure the rate or the progress of a reaction. The carbon dioxide leaves the flask, cause the mass to change, as you can see, because and what is the purpose of this cotton wool? So it does not let the content in the flask to escape. Only the gas can escape. The content in the flask, even we can keep it open. But what will be the, what might be an error if there was no cotton wool placed? So because maybe a violent reaction might occur and the splashing of the acid or the sample, the content in the flask may also come out. That's why, to avoid, we place a cotton wool. Plan an investigation using the apparatus shown in the diagram to find how the temperature of a dilute hydrochloric acid affects the rate or the speed of reaction. Your plan should include how your result will show the temperature of a dilute hydrochloric acid affects the rate of the reaction. And you're provided with dilute hydrochloric acid, calcium carbonate, and the common lab apparatus. So what we will do, we will take equal, basically for a fair comparison, we just want to change one parameter, and that parameter is the temperature. Rest all other parameters should be same. So we should take same amount of calcium carbonate. We should take same concentration of a hydrochloric acid, same volume of hydrochloric acid. Surface area of a calcium carbonate should also be same. So we'll take measured volume or equal volume of acid and add to a known volume, known mass of a calcium carbonate. and record the time, like, or record the volume change in the mass in 3 minutes or 5 minutes, and we'll repeat the experiment at a different temperature. So the first part, we will take, like, you can mention a specific volume, or you can also mention, like, take same amount of acid for each experiment. For example, take 10 cm cube of HCl, hydrochloric acid, at 20 degrees centigrade. Add known mass of calcium carbonate. After that, adding a known mass of a calcium carbonate, we will measure the change in the mass, like example, in 3 minutes or 5 minutes. Measure the change in mass in 3 minutes. Then what we'll do, we'll repeat the experiment with same volume and amount of calcium carbonate. At 30 degrees centigrade. And then what we will sketch, like how we will know the rate, how the effect or the rate is affected by temperature. So we will plot a graph between the change in mass and the time, and how we'll know which reaction is faster. So the reaction which shows a steeper slope so the reaction in which the slope of a line is steeper, that reaction is faster. So what we have to do, we have to simply find the effect of temperature on the speed or the rate of reaction. So we take equal amount of hydrochloric acid mixed with calcium carbonate at 20 degrees centigrade, and then we repeat the same experiment at 30 degrees. After that, we'll plot a graph. We don't have to plot a graph, we just have to mention what. Yeah, generally, because the question is not really, you don't have to mention it is the one which is at a higher temperature is faster, but you have to mention how you conclude your result, how you reach your like from the observation, how you draw the conclusion. So how we draw the conclusion, will record sketch a graph between mass and time, and the one which shows a steeper, like example, two graphs are there, this is one and this is the second. So the one which is steeper, as you can see, B is steeper. B is having an initial slope greater than A. So it means B is faster. You don't have to mention higher temperature is faster. It is obvious higher will be faster, but that is not having mark. The main thing is how planning of the experiment. Like the question is, your plan should include how your result will show how the temperature of hydrochloric acid affect the rate. So how our results show that how the change in temperature affect the rate. So we should plot a graph between mass and time, and the one which shows a steeper slope, it means that reaction is faster. And it is obvious, the one which is at a high temperature, like example, B is at 30 degrees and A is at 20 degrees. Then another question. We have tartrazine is a yellow food coloring. Plan an investigation to find if a yellow sweet, like example, maybe you have a, say this is a yellow sweet. We want to find this yellow sweet contain tartrazine. How we can identify or how we can find if this is a yellow sweet, because in a chromatography, we don't or we cannot use the solid, we have to make a solution. So what we will do, and your result should explain how your result will tell you if the sweet contain tartrazine, and you have access to all lab apparatus, a yellow sweet and a sample of a tartrazine. So example, we have a yellow sweet first. Then what we will do, we will dissolve this yellow sweet to extract the color. And as they did not mention it is a water soluble or insoluble in water, so you can use water as a solvent. So what we'll do, we'll take a container, fill it with water and add yellow sweet to this container and we'll dissolve. And when we dissolve, the yellow sweet will dissolve in water. Then we will take Then what we will do, we will take using a chromatography. I'm explaining the process and then I will write the points as well, that which include the answer. So we'll use a chromatography. Always mention we'll draw the origin with pencil. Then using a dropper, how we take the sample out, like this is a sample. So how we take a sample using a dropper, we'll place a sample of yellow sweet and a sample of tartrazine. And after that, we'll use a suitable solvent here because they did not mention it is insoluble in water. So you can use water as a solvent. So as a result, what happened when this chromatogram absorbed the solvent will rise on the chromatogram. As a result, when the solvent is rising, the sample will also rise with the solvent. If we get the spots, like a spot of the yellow sweet and the spot of a tartrazine at the same height or the same level, it means the yellow sweet contain tartrazine. But if it is not in the same level, like example, the yellow sweet and the tartrazine, they have a different level, it means that the yellow sweet does not contain this food color. And better, whenever a question is, you may, if here it is optional, you may draw a label diagram. Label diagram, like I have to label, this is a chromatogram, origin, sample, solvent. We have to mention all of this. So if a question is, you may draw a diagram, it's better you should draw a diagram so that maybe if you miss any point in the explanation, you will score the mark. In case you miss any point in the explanation, still your figure or a diagram will help you to score the mark. So it's better whenever even it is optional, you may draw a diagram, but it is better you should draw a diagram to answer these questions. So what we will do, the steps related to this. So first we'll dissolve a sweet in the solvent and we will use chromatography. After that, dissolving the sweet in the solvent, we will use chromatography. Then we will draw the origin on the chromatogram. By using pencil. Then place the sample and the tartrazine by help of heat pipette, or you can also say dropper. Then use a suitable solvent. Example, we use water here. Then allow the solvent to rise to the top. Then after that, you can measure the RF value or compare the heights. And if they rise to the same height, it shows the yellow suite contain tartrazine. So this is the experiment for identifying that a yellow yellow food coloring is present in the yellow suite.